In this lesson, we're going to be talking about sum and difference identities. We're just going to focus on cosine right now. And so here are our formulas. The idea of this is you're going to be talking about sines, cosines, tangents eventually of angles that we normally don't have. So the angles that we're familiar with are from our special two triangles of our 30, 60, 90 triangle and our 45, 45, 90 triangle. But if we have angles other than that, doesn't mean you can't figure out exact values. So with these two formulas and combining combinations of these angles to make 15 degrees, we're going to be able to figure out the exact value. So 15 degrees is a bunch of different ways that we can do it, but you could take 45 degrees minus 30 degrees. You could take 60 minus 45. It doesn't matter, it's all going to work out to be the same thing. So if we rewrite this, we're looking at doing cosine of 45 degrees minus 30 degrees, which is the bottom formula. So cosine of 45 times cosine of 30 plus sine of 45 sine of 30. And so cosine of 45 is why I draw the 45, 45, 90 triangle, the 30, 60, 90. So I don't have to memorize all the values to this. I could just pull the information from this. So cosine is going to be adjacent over hypotenuse, which is 1 over root 2, which rationalizes into root 2 over 2. And then cosine of 30 is root 3 over 2. And then plus sine of 45 is opposite over adjacent, another 1 over root 2, which rationalizes to root 2 over 2. And then sine of 30 is 1 over 2. So if we put all the stuff together, we get ourselves a root 6 over 4 plus root 2 over 4. We have common denominators, so the best that we can do is rewrite it like that. So that feels like an ugly answer, and it is, but if you were to plug this into a calculator, cosine of 15 degrees, it's going to give you some decimal, and if you plug that into the calculator, it should give you the exact same decimal. So that's how you can double check to make sure you're heading in a good direction. Let's try one more. If you're going to do cosine of 5 pi over 12. So the radians is a little bit trickier, just not as straightforward as trying to come up with angles with degrees, but you're still trying to find 5 pi over 12. So we want to break something into twelfths. Now we got to be strategic about this, that we need things to simplify into pi over 6s, pi over 3s, pi over 4s, because those are our radian versions of these angles. So us doing something like a pi over 12 plus a 4 pi over 12 is not helpful because this thing won't simplify. So if we make this a 2 pi over 12 plus a 3 pi over 12, those will simplify, and this will just become a pi over 6, and this would become a pi over 4. So that's a 30 degree reference angle, that's a 45 degree reference angle, perfect. So we're going to do cosine of pi over 6 plus a pi over 4, and that's going to make cosine pi over 6 times cosine pi over 4. Because it's the plus, we have the top formula, so it's going to be a minus sine pi over 6 times sine pi over 4. So cosine of pi over 6 is cosine of 30, which is root 3 over 2. Cosine of pi over 4 is 45, so that is our 1 over root 2, which rationalizes, so adjacent over hypotenuse. And then minus sine of 30, so 1 over 2. And then this is going to be another 45, so it's a root 2 over 2. So this becomes root 6 over 4 minus root 2 over 4, which then equals root 6 minus root 2 over 4. And again, you can plug it into the calculator, plug this into the calculator, make sure you're in radians, plug this in the calculator, you should get the exact same decimal. And if you notice the values associated with this, you're going to have a lot of combinations of 30s, 60s, and 45s. So it's not going to be uncommon to have these root 6s minus root 2s, or root 2s minus root 6s, or they're going to be added together. Just some sort of a combination, pretty much of that is going to happen over and over and over again. There is one last kind of problem which looks more complicated than it is if you're sitting with, let's say, cosine of 87 degrees, cosine of 93 degrees, minus sine 87 degrees, sine of 93 degrees. So the idea is this, it looks like, well, what do you do with this? The idea is for you to just recognize which formula you got and actually pull it back. So you're looking at the top formula with cosines here with a minus and then sines here. So you're looking at the top formula. So we could rewrite that as cosine of 87 degrees plus 93 degrees, which is really cosine of 180 degrees. And it's not at all a coincidence that when you put these angles back together, it's going to turn out to be something nice, whether it's in degrees or radians. It's going to be something that's going to be a 30-degree reference angle, or a 60, or a 45, or this, which is going to land on an axis. So we are looking at 180 degrees. So we're looking at that point, and cosine is an x. So we just get a -1 out of it. All right. So this is more of a recognition, where this is a little bit of a trickier idea of let's figure out what angles we can put together and then just plug it into the formula. All right, so that was sum and difference identities of cosine.